All right, class, we're going to start chapter 8 today, and we're going to start off by, so chapter 8 is about alcohols, phenols, ethers, and their sulfur analogs. So we're moving on from, hydrocarbons, and we're starting to add some heteroatoms and thinking about the chemistry involved with heteroatoms, so oxygen, nitrogen, but we're focusing most of the rest of the semester on oxygen. It turns out oxygen is found in all kinds of different molecules, super common, and it imparts a lot of different interesting chemical properties uh, to molecules when you put oxygen in them. All right, so there's going to be a series of lectures about. We're going to start off today with this lecture. What this video lecture is going to be about is about naming alcohols, ethers, and phenols. And then we're going to move on to the boiling points of alcohols and the acid-base properties of alcohols, and then reductions of ketones and aldehydes. And we might go into the boiling points of alcohols right now, depending on how long this runs. Okay, so let's start with the naming of alcohols, phenols, and ethers. So first off, I just want to go over how we can just generally talk about an alcohol, describing the type of alcohol. And so when we talk about an alcohol, there are three types. We can have what we call a primary alcohol, we can have what we call a secondary alcohol, and we can have a tertiary alcohol. This terminology is completely analogous to like when we have primary, secondary, and tertiary halides. What we're talking about is the number of carbons that the carbon attached to the OH is. So when we talk about an alcohol, the OH is really the thing that is dictating something being an alcohol, right? So an alcohol is something that has this on there. And when we talk about a primary alcohol, it's this carbon right here being attached to just one carbon. Secondary alcohol, this carbon attached to the OH is bound to two carbons. In a tertiary alcohol, this carbon bound to the OH is bound to three carbons. So we can talk about an alcohol being primary, secondary, or tertiary. Now we know this is important because if you go back and you think about SN1, SN2, E1, E2, whether the electrophile was primary, secondary, or tertiary, that sometimes dictated, or a lot of times it dictated, what type of reaction mechanism is taking place. Now, as far as naming alcohols, kind of technically, we're adding a new suffix. So the new suffix that we're adding here is OL, right? So we're basically adding a new suffix to talk about OL. So what we're going to do is you want to find the longest chain that contains what we call the hydroxyl group, or the hydroxy group. I think this is supposed to be hydroxy. So the hydroxy group is what is termed as the OH. So what we're looking for is the longest chain that has the OH. And then you're going to replace the E of that longest chain, that base chain name, with OL. And then you're going to number the chain so that the hydroxyl group gets the lowest number. And so that's going to take priority over the other things. And then you're going to number the substituents in the chain and then list the chains alphabetically. So for example, if we look at this molecule here, we're going to find the longest chain. And the longest chain is this one right here, pentane. So you go from pentane, you drop the E to pentanol. So this is good, the E drops and you go to pentanol. We then number it so that the OH gets the lowest numbering. So if I go from left to right, 1, 2. Whereas if I go from right to left, 1, 2, 3, 4. So because the OH is on carbon 2 versus carbon 4 this way, we're going to number from the left to the right. So one of the things, just like with alkenes and alkynes, is you have to put the location of the suffix, of where the OH is. So remember, the old way of naming is you would put the number out front of the parent, but the new way is you put the number between the parent and the suffix. And then we have the methyl group, so the substituent here is at 2. So 2-methyl, pentane, 2-ol. The same thing for cyclic systems. Now again, when we do cyclic systems, we want to number it so the substituents get the lowest number. You start numbering from one of the OHs, so 1, 2, 3, 4. So remember, notice that we have this here, the di, because there's two alcohols. And notice that we're using this prefix here, the cis, because these two OHs are on the same side of the ring. So cis cyclohexane 1,4-diol. One thing to notice here is that when you put the location of the OHs between the parent and the suffix, you don't want a consonant following another consonant. That's just IUPAC nomenclature. So you don't drop the E here. Now here we're gonna find the longest chain with the OH, 1, 2, 3, 4, and we're gonna number this way because if you number the other way, 1, 2, 3, this carbon gets 3. The OH carbon gets 3, right? So we go from this way. So this is a phenyl group. So this phenyl group is at carbon 3, right? So 3-phenyl butane 2-ol. So we're basically adding a new suffix. That's basically what's happening here. We can combine alkenes and alkynes with the naming of alcohols. So in this case, one of the things to keep in mind is that the OH, when you're numbering here, the OH takes priority over alkenes and alkanes. So the OH takes priority over alkenes and alkynes. Okay, so what that means is I go 1, 2, 3, 4, 5. Now, so I go. This is how I number it, right? 1, 2, 3, 4, 5. I don't number it. Let me see if I can get a different color here. We'll do this blue. I'm not going to number it the blue way. 1, 2, 3, 4, 5. The red numbering is correct because the OH takes priority over the alkene. Okay, so that's what we want to keep that in mind. The alkene takes priority over, or the alcohol takes priority over the alkene. Okay, so this becomes, and then you still have the suffix in there, right? So ene all. So this becomes pent 4-ene 2-ol because 1, 2, 3, 4. So the alkene is at 4, the alcohol's at 2. So again, here 1, 2, 3, 4, 5. So 4-pent-ine all. Notice the all comes at the end, and this isn't alphabetical, so it's not pent-all-ine. It's pent-ine all. So the all comes at the alcohol comes at the end here. Now for phenols, we've already gone over phenols or a little bit, so let's just go over this really quick. So this is called, this would be phenyl methanol, 2-propene-1-ol. These are the common names above it. So these things up here are the common names of these alcohols. So this is benzyl alcohol. The IUPAC name would be phenyl methanol. This is the common, this is allyl alcohol. The IUPAC name would be 2-propene-1-ol. This is tert-butyl alcohol. The actual IUPAC name would be 2-methyl-2-propanol. Ethylene glycol, 1,2-ethane-diol is the IUPAC name. This is glycerol, 1,2,3-propane-triol. All right. Now, as far as phenols, we've gone over that already. You are going to name. We've already gone over that in the aromatic chapter. So if I have a phenol, so phenol is something that looks like this. A phenol is an OH on an aromatic ring, like this. And this is a phenol. And so remember, you name this as a phenol, and then any other substituent starts from the numbering of that, on that, wherever that OH is. All right, so let's go over naming ethers. So there are two types of ethers. There's kind of what we call simple ethers, and then kind of more complicated ethers. So a simple ether is where, so first off, let's go over what an ether is. So an ether is a molecule where you have an oxygen attached to two alkyl groups on either side. So the way it differs from an alcohol is that in an alcohol, the oxygen is bound to a hydrogen on one side and an alkyl group on the other. So in an ether, they're bound to two alkyl groups. And so in a simple ether, the both alkyl groups would have a simple alkyl name, right? So this is a methyl group, this is an isopropyl group. So when both of the alkyl groups are simple alkyl names, you simply name them as, you simply name the alkyl groups and alphabetize them. So for example, this is an isopropyl group, methyl group, isopropyl, methyl, and then you throw ether on the end. This is a phenyl group, right? So this is phenyl. So this is phenyl. This is ethyl. So ethyl, phenyl, ether. Now sometimes the alkyl groups aren't simple. So for example, this is a methyl group, but this is not a phenyl group right here. So we can't just name that as a simple. We can't name that methyl or methyl phenyl ether. So what we have to do is we have to name this as a substituent on. We have to name this as a substituent on an alkane chain. So when you name this as a substituent, what you do is you go from methyl. So you go from methyl. You drop the YL and you add OXY, and that becomes methoxy. So you start calling it an alkoxy group. So this is a methoxy group because methyl to methoxy. This is also a methoxy group, methyl to methoxy. So these are para to each other on a benzene ring. So para dimethoxy benzene. So for example, I can't name this as a simple alkane group. So I have to name this is tert-butyl. So this goes from tert-butyl drop the YL, add OXY to tert-butoxy. Now, because this is now a substituent on a ring, I'm going to name this as if it was a cycloalkene ring. So 1, 2, 3, 4. 4 tert-butoxy, 1 cyclohexene. All right, so why don't you take a minute or more than a minute? Why don't you just pause the video right now and try to come up with the names of each of these compounds. All right, welcome back. So hopefully you tried to come up with the names of these compounds, and these are the names, these are the answers that you should have come up with, okay? So notice here, what I have here is this is an ether here. This is not a simple ether because this is a more complicated alkane name. So this is an ethoxy group. So methyl, and this should be hexene, sorry. So this is a typo on here. This should be, right here, this should be hexene, okay? So 1, 2, 3, 4, 5, 6, so hexene. So this is, again, not a simple ether, and so we're gonna have to name this. This is a phenyl group, right? So this becomes phenyl to phenoxy, cyclohexane ethyl group, 1 ethyl, 3 phenoxy, cyclohexane, 1, 2, 3. Again, not a simple ether, and it's an alcohol. So what we're going to do is this is going to be isopropoxy. This is going to be 1, 2, 3, 4 butanol, 1 butanol, 1, 2, 3 isopropoxy. This is a simple ether. So this could be tert-butyl methyl ether. Notice that when we alphabetize, we don't include the tert in there. This is a combination of an alcohol and an alkene. 1, 2, 3, 1, 2, 3, 4, 5. So we're going to number 1, 2, 3, 4, 5, 6, 7 because the alcohol takes precedent. So the alcohol is at 3, the alkene is at 5. So, and then this is a trans double bond here. So this double bond is trans, so we have to put the trans in there. Hep trans 5-ene 3-ol. So pentane 2,4-diol, that's relatively, I think, straightforward. These are phenols, so 1, 2, 3, 4. And then this is an ethoxy group. So 1, 2, 3, 4. 1, 2, 3, so 3 ethoxy, 4 nitrophenol. And then this is isopropyl, and it's para to the phenol, so para isopropyl phenol. All right. So I hope the naming of alcohols made sense. Let me know if you have any questions, and I will see you, or you will hear me um, next lecture. Thanks, and I will see you next lecture.